y'all. Today we're going to take a look at triangle theorems. So that is our goal for today. Yesterday, the past couple of days, we've been looking at special angle pairs. Today we're going to focus on triangles. So here we go. We have an acute triangle. So first we're going to classify the triangles by their angles, and then we're going to classify by the sides. So if we classify the triangles by angles, the first type is an acute triangle. This would be a triangle with 3 acute angles. So I've drawn here. Acute angle is less than 90, so that is my representation. It's lots of them out there. That's just the one that I happen to draw in. An obtuse triangle is a triangle with 1 obtuse angle. So it has 1 angle that is greater than 90 degrees. So this is the angle that I'm referencing here. It is greater than 90 degrees. A right triangle is a triangle with 1 right angle, and a right angle is 90 degrees. So this little mark here means that I have a right triangle that is 90 degrees, and there's only one of them in this triangle that it could be, and there's only one obtuse angle in here that it could be. An equal angular triangle is a triangle with all equal angles. So an equal angular triangle is a triangle with all equal angles. So here we are here. And so all of these angles are going to be the exact same measurement. And if there's 180 degrees in a triangle, then if I do 180 divided by 3, each of these has to be 60 degrees. So 60 plus 60 plus 60 would give me the 180 degrees that are in a triangle. So those are the type of triangles by angles. Now, if I classify the triangles by size, then a scalene triangle is a triangle with no congruent sides. So this side is a measurement, this is another measurement, and then this is still another measurement. So these tick marks mean that they're all 3 different measurements, so no congruent sides. Isosceles triangle, a triangle with 2 congruent sides. So these tick marks are the same and they're congruent, and then this is a different measurement. So maybe both of these are 5 and then this one is 10, or both of these are 11 and this one is 20 or something like that. Equilateral triangle, a triangle with all congruent sides. So whatever this is the same as this, is the same as this. So they have the same measurement. A regular triangle, a triangle that is equiangular and equilateral. So prefix EQUA means the same, equivalent to each other. So a regular triangle, like I've drawn here, all 3 angles are the same, like we see over here for equiangular. So they're all 60, 60, 60. And it's also equilateral because all the sides are the same. So this is a regular triangle. So there are 4 types of triangles by angles, and then 4 types by their sides. Okay, let's talk about the triangle angle sum theorem. So the sum of the 3 angles of a triangle always equal 180 degrees. So I said that a few minutes ago. So the triangle angle sum theorem states that the sum of the 3 angles of a triangle always equal 180 degrees. So regardless of what you do in a triangle, they're going to add up all to be 180 degrees. So let's take a look at some examples. So we're going to go through 4 examples, and all we need to know is if I add up all the angles in that triangle, it's going to equal 180 degrees. So let's start with A. So this is 42 degrees, 93 degrees, and this is X. So I know when I add all 3 of these up together, it should give me 180 degrees. So we can do 180 minus 42 plus 93. So I'm just going to add these up, subtract from 180, and we'll get that X is 45 degrees. Next, I have another one, same concept. I don't know what one of the angles is, but I do know that these have to sum to 180 degrees. So this is X, this is 90 because this mark here means it's a 90-degree angle, and this is 37. So this turns out just like the first example we did. We're going to add the 90 and 37. Because together it has to give us 180 degrees. So I'm going to add those together, and it's going to give me 53 degrees. So 53 degrees. Again, the only theorem I'm using so far is that if I add them all up, it gives us 180 degrees. All right, C. So I have this, and this one over here, but I'm not sure what this is. So I have a few different ways I can do this. I know that this angle plus this angle equal 180 degrees. I know that because this is a straight angle and they form a linear pair. So a linear pair is going to add together to be 180 degrees. So the first thing that we're going to do is 180 minus 147. So these two together give us 180. So I'm going to subtract to figure out what this angle right here is. So this is going to give me 33. So let's label that in our picture. So I now know that this is 33 degrees. Now it looks like the problems problem A and then problem B. I can add these two up and I can subtract from 180. So 180 minus, add these together. Okay, so I'm going to add these two together and I'm going to subtract from 180 and that'll give me the measure of x. So I got 97 degrees. So x is 97 degrees. In triangle ABC, the measure of angle A is 5x plus 2. The measure of angle B is 2x plus 2. And the measure of angle C is 2x plus 11. So I know again, the only thing I know so far is that if I add them all up, we get 180 degrees. So 5x plus 2 plus 2x plus 2 plus 2x plus 11 is equal to 180 degrees. So this is A, this is B, and this is C. So if I add all three of these angles up, it's going to give me 180 degrees. So we got to add up like terms. 5x, 2x, 2x. So 5, 6, 7, 8, 9. I got 9x. We're going to add up our numbers. 2 plus 2 plus 11. That's going to give me 15. So I did like terms, x's, add up all the x's, and then I add up all the constants, the regular numbers, and that's going to equal 180. Subtract 15 from both sides. That gives me 9x equals 165. And divide both sides by 9. Okay. In this case, it's going to be more appropriate. Excuse me, sorry, to make sure you can see there. So in this case, it's going to be more appropriate for us to leave our answer as a decimal. So as a decimal, this is about 18.3 repeating. So 165 divided by 9 is 18.3 repeating. So it'll be more appropriate in this case for us to figure out what x is by just leaving it as a decimal. So that is the triangle angle sum theorem. Now we're going to take a look at another theorem. All right, this time we're going to take a look at the isosceles triangle theorem. So if I bring this back down, isosceles triangle, a triangle with two congruent sides. So we want to keep that in mind. Isosceles has two congruent sides. So the isosceles triangle theorem says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. And we got a picture here, so we're going to draw in some tick marks so we can know what's congruent to each other. So those two sides are congruent to each other because it's an isosceles triangle. So this theorem says that, okay, if these two sides are congruent to each other, then these two angles are also congruent to each other. So this angle and this angle are congruent. So if I have two congruent sides, the angles opposite those sides are congruent. So this angle, opposite here, opposite the side, and then this side is opposite the angle. So these are congruent, and then these are congruent. These side lengths are congruent, and these angles are congruent because they're opposite. Okay, let's try an example. Okay, example 2. Triangle AMK is isosceles with base AM. The measure of angle A is 6x minus 10, and the measure of angle K equals x plus 5. And this should be x plus 5. There we go. Find the measure of angle A, angle M, and angle K. So let's definitely draw a picture so we can kind of get an idea of what's going on. And we're going to label this A, M, K. Let's see what we know so far. We know that the measure of angle A is 6x minus 10. So I'm going to label this 6x minus 10. And it's an angle, 6x minus 10. Much better. So I'm going to measure this, I'm going to label this angle 6x minus 10. Then if I keep going, and we know that the measure of angle K is x plus 5. And we are tasked with finding the measure of angle A, M, and K. So I know that if this is 6x minus 10, okay, this is also 6x minus 10 because it's an isosceles triangle and this is the base. AM is the base, it's the bottom, so this is congruent to this. So that side is congruent to this side because these angles are congruent. So that means that this is also 6x minus 10. So that is also 6x minus 10 degrees. All right, so let's go through and we're going to set it all up equal to 180 and solve. So 6x minus 10 plus 6x minus 10 plus x plus 5 all together equals 180. So this problem is going to turn out like example D from up here. This is one angle, this is a second angle, this is the third angle. So I'm going to take all three of these angles and add it to, set it equal to 180. So 6x, 6x, okay? So that's going to give me 13x. Put my numbers together. Negative 10 plus negative 10 plus 5 is going to give me minus 15. Okay, opposite of negative 15 is to add 15 to both sides. So now we have 13x is equal to 195. And divide both sides by 13. Opposite of multiplying by 13 is to divide. So we got our answer is 15. Now this isn't our final answer. We now need to take 15 and substitute it back into my angles. So we need to take 15, substitute it into 6x minus 10. Take 15, substitute it into x plus 5. So my first substitution, we're going to do 6 times 15 minus 10. So I took 15, made a substitution. That's going to give me 80. And we're going to take 15 and substitute it into x plus 5. So clearly 15 plus 5 is going to give us 20. So the measure of angle K is 20. This one's 80. And this one's 80. So these two angles here are both 80. And this angle up here is 20 degrees. All right, I want to do some more problems before you go off and try today's assignment. So we're going to be using the fact that there's 180 degrees in a triangle, and if it's an isosceles triangle, then we're going to use this theorem right here to help us figure out what the missing angle measure is. All right. Make sure you can see there, and here we go. So find the value of x. So I see that this is an isosceles triangle. I see these two tick marks means that they are equivalent to each other. So the opposite angles are equivalent. So that means this one is 65. So for this one, all we got to do is 180 minus 65 plus 65. Absolutely, you can use a calculator, not a calculator, but a calculator, excuse me. So I don't have to do this right here, mental math. You can plug it in the calculator. So 50 degrees. There we go. Okay. For B, same kind of thought process. If it might help you to turn it and maybe you can see it. I think we're used to seeing the isosceles triangles like this with my tick marks here. So this is 40x. So that means that these two have to be the same measure because they're opposite my little tick marks here. So this one is also x. So I do want you to get comfortable seeing it in different shapes and things like that. But it's okay to leave it like this or turn it. Just do what you need to so that you can see that these two both have to be x. So this is x plus 40 equals 180. So I'm going to add these together. This is going to give me 2x plus 40 equals 180. Okay. The opposite of a positive 40 is to subtract 40 from both sides. And I'm going to come up here and write, okay? So 180 minus 40 is going to give me 140. So now I have 2x equals 140. Divide by 2. X equals 70. So the answer to this is 70. C, I know that this is 90 degrees. These two tick marks means that those two sides are equivalent and it's an isosceles triangle. So opposite of this is going to be x because opposite of this is going to be x. Okay. Now this problem looks like the previous one we did. We're going to add my two x's together. Okay. So this is going to give me 2x. We're going to subtract 90 from both sides so that we get 90. And 90 divided by 2 is 45. All right, a few more. All three of these tick marks are the same. This are all the same. So that means that all of my angles automatically have to be the same because this is a regular triangle. All the angles and all the sides are the same. So x plus x plus x is equal to 180 is the equation that we're setting up. So take all three angles, equal it to 180. This is the one that we did earlier, and we know that all the angles are equal to 60 degrees. And the more you see this triangle, you won't have to set up this stuff at all because you'll automatically know a regular triangle, the angles are 60 degrees. E, I know that these two are the same. So I know that this is x. So let's introduce a new variable. So if these two sides are the same, these two angles have to be the same. So let's say that this is angle y, and then this is angle y. I don't know what it is, but I know that they are the same measurement. So if I do 30 plus y, if I add up all these three angles, it's going to equal 180 degrees. So 30 plus y is equal to 180 degrees. Add this together. So that gives me 30 plus 2y equals 180. Subtract 30. That gives me 2y equals 150. And 150 divided by 2, I'm going to come in right up here. That gives me y is equal to 75. So I did 150 divided by 2, and it gives me that y is equal to 75. So that means that this is 75 and this is 75. So we can label that 75, and this one is also 75. So I labeled this as 75 and this is 75 because they're congruent to each other. Now I'm looking for the measurement of x. So I know that this is a linear pair. So I now need to do 180 minus 75. And when we do 180 minus 75, we'll get our answer, which is 105 degrees. So 105 degrees. And last but not least, F. Very similar. I know that this one is x. I got my two tick marks here. So this is an isosceles triangle. And I need to find my angle measures here. So let's introduce a new variable since I don't know what this is. But I know that they're both y. Okay, other things that I can do. I know that this here, together, they make a linear pair. So this and this make a linear pair. So we can do 180 minus 125. And I now know that y is 55 degrees. So these two make a linear pair. Together, they equal 180. So if I do 180 minus 125, it'll give me 55 for each of these. So that's 55, and then this 55. So x plus 55 is equal to 180. X plus 55 is equal to 180. So 180 minus the sum of these two angles. And voila, my answer is 70. So the answer for this is 70 degrees.